Welcome to Learn DirectMesh. DirectMesh is an intelligent rhinoceros plugin for efficient mesh and finite element model generation, allowing you to easily create complex finite element models within Rhino's interactive environment. It supports mainstream finite element analysis software such as Abacus, ANSYS, FLAC3D, Midas, Multifrax, and Nastran. To use this software, you must first install Rhinoceros version 7 or above. After running the installer, the DirectMesh plugin will be loaded when you run Rhinoceros. Before using DirectMesh, we need to understand the following concepts. 1. Geometric entities, such as points, point clouds, curves, surfaces, and solids. 2. Meshes, which are collections of triangular and quadrilateral faces. These faces are called mesh faces, their vertices are called nodes, and the edges of mesh faces are called mesh edges. Meshes are divided into unstructured and structured meshes, with structured meshes being more regular. 3. Finite element models, which are collections of elements. The vertices of elements are called nodes. Elements are divided into point elements, e.g., concentrated masses, line elements, e.g. beams and columns, surface elements, e.g. shells and membranes, and solid elements, e.g. tetrahedra, pyramids, wedges, and hexahedra. The finite element modeling workflow using DirectMesh starts by creating an initial mesh from geometry, then refining the mesh, and finally building the final finite element model using closed surface meshes representing solid elements, independent meshes representing surface elements, polylines representing lines, and points representing point elements. The details are as follows. Step 1. Create various geometric models into initial mesh models. The DREAD command can load various geometric models. The DMesh command can convert geometric models into initial mesh models, e.g. generating corresponding meshes from solids or point clouds. The DExtrude command can extrude a mesh along a curve to form a closed mesh, e.g. extruding a tunnel cross-section mesh along the tunnel axis to create a mesh model representing the tunnel. The DProject command can project contours onto a surface and generate corresponding closed meshes, e.g., projecting a mesh representing the ground surface onto a plane and generating the corresponding mesh model. The DDiagnose command can be used to diagnose conflicting faces, holes, and collinearity in a mesh. The DRepair command can automatically fix errors in the mesh, e.g. repairing conflicting faces, holes, cracks, protrusions, duplicate nodes that are identical or adjacent, non-coplanar quadrilateral mesh faces, etc. It can also merge two triangular mesh faces sharing an edge and being coplanar into a quadrilateral mesh face. Step 2. Refine the mesh model. The DMerge command can merge multiple meshes and curves with shared nodes. Meshes representing multiple structures that intersect without shared nodes usually cause finite element analysis to fail. This command solves that problem. The DEdit command can edit the position of nodes in a mesh. The DDelete command can delete redundant mesh faces. The DHatch command can extract all nodes of a mesh to generate a point cloud, extract mesh edges as a skeleton, or generate the boundary edges of a mesh. The DEmbed command can embed a polyline into a mesh with shared nodes, e.g. embedding a polyline representing rails into a mesh representing the ground. The DSeparate command can segment a mesh based on a separation angle and other criteria. This function can partition the mesh, facilitating the addition of boundary conditions and load conditions in the final finite element model. The DColorize command can randomly color meshes and various geometric models for easy distinction. Finally, the DRemesh command can be used to perform high-quality remeshing, controlling overall size and local size in specific areas, preserving fixed points, fixed edges, and fixed mesh faces, supporting both structured and unstructured meshes. Step 3. Use the dbuild command to generate the final finite element model input file, which also outputs the corresponding finite element model in Rhinoceros. It supports mainstream finite element analysis software such as Abacus, ANSYS, FLAC3D, Midas, Multifrax, and Nastran, supporting solid elements, surface elements, line elements, and point elements. Closed meshes automatically generate corresponding solid elements. Add Adding the user-defined property type equals face element to a mesh generates corresponding surface elements. Adding the user-defined property type equals line element to a polyline generates corresponding line elements. Adding the user-defined property type equals point element to a point generates corresponding point elements. The output finite element model retains all element group information. You can then load the corresponding model into commercial finite element software for analysis. To model more freely and efficiently, you also need to master the basic usage of Rhinoceros appropriately, such as the distance command to measure the distance between 2 points, the move command to move geometric objects, the bounding box command to generate the tightest bounding box of a geometric object, the point command to create specified points, curve tools to create various curves, surface tools to create various surfaces, solid tools to create various solids or perform Boolean operations on solids, etc. Additionally, you need to learn the layer operations provided by Rhinoceros, such as showing, hiding, locking, and unlocking. Changing the view mode, e.g. wireframe, shaded, rendered, can help you better view the model. Upon first use, DirectMesh will automatically bind to the computer and can be used free for 14 days. After that, users need to purchase a license via WeChat Pay to continue using it. You can purchase a license using the dbuy command. The WeChat payment order number is the license. Then you can use the deauthorize command to bind the license to your computer. The dcheck command can check the remaining usage time on the current computer. The dorter command can view all licenses under the user's registered email. That concludes all the DirectMesh operations. Thank you.